So let's talk about how number base is applied in securing data. Whenever you try to send information via Bluetooth, that data is always secured before it gets transmitted to the receiving device. And I'm going to give you a glimpse into how that transfer takes place, how that data protection takes place. So when you try to protect data, you call that encrypting. Encrypting is a way by which you protect data before you transfer. So what I mean is this. I'm going to give you an idea as to how we can use how number base is used for data encryption, right? For data encryption. So data encryption means data securing data before transmitting, basically. That's what it means. So how do we encrypt data before sending to a receiver using number base? So this is what happens. The first thing to explain is every character you type on your computer or on your phone, they are represented as numbers or digits by the computer. Every character has a representation. And one of the one of the standard used in representing information is known as ASCII. So ASCII stands for American Standard Code for Information Interchange. So it's a kind of universal standard used by all computer whenever they want to store information. So what I mean in plain terms is this. If you type letter A will be stored, will be encoded or stored as this capital letter will be stored as 65. Letter B is going to be represented internally. Computer will store it as 66 and the list goes on. So what I have on the left is a list of uh, encoding for various characters. So if you type space on your computer, space is represented as 32. That's how computer will receive that information. It will receive that information as if you've given it a command or 32. It encodes it as 32. Then if you check, you will see that 0, which is character 0, is stored as 48. And this is just the table of uh, character encoding. So it's just a way by which computer uses to know, okay, A is this number, B is this number, and so on and so forth. Now, given this number, how can we secure information when before transmitting to a receiver? So let's think about it this way. So let's say you have Alice here. Alice has an information that needs to be sent. And let's say that information is love. So let's say this secret information and that secret information is love. And Alice wants to send that information to Bob, right? And this time around, Alice wants to send it in such a way that whoever is listening here, so whoever is trying to tap into what is happening, will not get to know what's happening. Because whenever you transmit information, that information can be tapped by any receiver aside the person you are sending it to. So if a particular hacker is actually paying attention to the transmission process, he or she can actually have a copy of whatever is transmitted to the other person. But what if you don't want the hacker or whoever is listening to decode what you are saying? How can you secure it using number-based concept? How can you secure it? So one way to secure it is to scramble this love in a way that doesn't make sense and then transmit it to Bob so that whoever gets to read it will read nonsense, will not be able to understand what you've sent. So how can we do this using number base? So I'm going to give you an idea of what happens when you transmit information via Bluetooth. This is just a simplified version of what happens when an information is transferred via Bluetooth to another device. So let's take a look at the detail. Okay, let's talk about how Alice can encrypt the message, which is love, before sending to Bob. But before I talk about that, let me explain a concept which we are going to use. So this concept is called exclusive OR. It's a kind of operation in number base that is a little bit different from what we've done so far, but it's very similar. So I'm going to introduce it this way. The typical way of adding. So let's say I want to add two number bases. So I have 1, 0, 1, 1, 1. And I want to add it to 1, 1, 0, 1. So what I do typically here is I'm going to say 1 plus 1. So let's say I want to add, and they're both in base 2, right? If I add 1 plus 1, that gives me 2. So in this case, I'm going to write 0 because how many 2 can you find? 2. That is 1 remainder 0. So I'm going to transfer, carry the 1 here, right? 1 plus 1 plus 0, that's 2. You write 0, carry 1 because you're in base 2. So you take 2 out of the 2. So 1 plus 1 plus 2, that will give you 3. How many 3? How many 2 can you find in 3? That is 1 remainder 1. Then you add this, that's 2. How many 2 can you find in 2? That's 1 remainder 0. 1 plus 1, that's 2. How many 2 can you find in 2? That's 1 remainder 0. And you have this one. So this is how you do your normal addition. But there's another kind of addition which is called exclusive OR. It's a kind of addition where you don't carry over. So let's write a symbol like this. So if I want to add this using exclusive OR, that is I want to perform exclusive OR on this. What I'm going to do is I'm going to say 1 plus 1, which is 2. Then if you take 2 out of 2, that will give you 1, then remainder 0. You write the remainder, but you will not carry that one. So whenever you need to carry 1, you will not carry it. So when you add 1 plus 0, that will give you 1. Then if you add 1 plus 1, that will give you 2. So you take out 2, you will left with 0, but you won't carry the 1. Then 0 plus 1, that will give you 1. Then you bring down 1. So this is not a typical addition. It's called exclusive, or it's a kind of addition where you don't carry over, right? But there's one interesting property about this thing. If you take this answer and you perform this exclusive OR on this answer, you take the same value, this same 1, 0, 1, 1. If you add it to the result here, it will give you the original result. So let's work it out. 0 plus 1, that will give you 1. 1 plus 0, that will give you 1. 0 plus 1, that will give you 1. 1 plus 1, that will give you 2. So how many 2 can you how many 2 can you find? So that's 1. Then remember what? 0. You won't carry any 1. So in this case, you have 1 left, and that's this. So if you check closely, you see that you go back to this. So this principle is what is used in a lot of data exchange, especially whenever you transfer information via Bluetooth. It uses a special kind of addition of number bases. Now, why is this very interesting? If we take this 1101 to be our key, we call this the key. The key is more or less like a kind of is what you use to lock the information. So let's take this as the information. So this is the key. The original information is the plain information. So this is the plain information, right? Then when you add this two, you're going to get 11010, right? So this is what we call the encrypted information. So this is the encrypted info, right? Now, the interesting thing is if I have a particular key and I perform this special addition with this plain info, it will give me this encrypted info. And then if I add this same key to the encrypted info, it gives me back the plain info. So the basic idea is, imagine I want to send an information of 10111 to someone. I can add this key to it, and that will give me this information. that person is going to receive this information, whereas the original information is this. But then if the person has my key, if we have already exchanged key earlier on and he knows that I'm using a key of 1101, it's going to add that key back to the encrypted information, and that will give that person the plain information. So the idea of key is very important in data security. In fact, that is basically what determines if a data is secured or not. The key, this particular key, is used to lock and it's also used to unlock. So if you lock a plain information, you will get an encrypted information. If you add that same key to the encrypted information, it gives you back the original plain information. So that is the principle behind how data is secured whenever data is transferred from one point to another point. So I'm going to give you an example using this concept. I'm going to demonstrate an example where Alice wants to transfer a message, which is love, to Bob. So let's take a look. So the original message is L, O, V, and E. So in this particular case, our key, I'm going to use a key of 0110101. So that's what my key is going to be. Now, this is the original message, which is love. But Alice will not send this original message to Bob, because if Alice sends it, that message is not secured. Anybody can read that information and know what that information is. So how can I secure it using this key? The way you do that using number-based principle is you first determine this L. You convert this L to a number in base 10. And in the world of computer, L is the value of L can be determined using this ASCII table. This ASCII table I told you about. So it is a standard used by all computer manufacturers to determine what L is in base 10. So L in base 10 is 76. Capital letter O in base 10 is 79. Capital letter V in base 10 is 86. And capital letter E is 69. So the next thing you want to do is to convert each of this number to base 2. L, which is 76, in base 2 is 100. L, which is 76, in base 2 is 1001100. So if you convert 76 to base 2, you get 1001100. Then letter O, which is 79, in base 2 will give 1001111. Then 86 to base 2 will give, which is letter V, will give 1010110. Then 69 in base 2 will give 1000101. So what's the next phase? The next phase is to perform exclusive OR to this, that's this special addition. Perform that with the key. So add the key to each of these. So you have 0, 1, 1, 0, 1, 0, 1. Then here you have 0, 1, 1, 0, 1, 0, 1. Here you have 0, 1, 1, 0, 1, 0, 1. And then you have 0, 1, 1, 0, 1, 0, 1. So if you perform this special addition, you're going to get 0 plus 1, that will give you 1. 0 plus 0, that will give you 0. 1 plus 1, since you are not going to carry anything, is 0. You are not carrying anything. 1 plus 0, that's 0. 1 plus 1, 0 plus 1, that's 1. This is 1, and this is 1. So this is what you get for L. Then what you get for, so let's go over it again. This is 1, 0, 0, then this is 1. This 1, not 0. Then here you have 0, then 1, 0, then 1, 1, 1, and 1. So the next is for the V. So that's, mind you, we're not doing the typical addition, we're doing the exclusive OR, which is a special addition. So this is going to give you 1, 1, 0, 0, 0, 1, 1. And lastly, we have 0, 0, 0, 0, 0, 1, 1, 1. So this is the base. These are all in base 2. So this is what we're going to send to Bob in base 2. But then we need to convert them back to base 8. Sorry, to base 10. So if you convert this to base 10, that will give you, this L will give you 1, 2, 1. If you convert this to base 10, it will give you 1, 2, 1. This will be 1, 2, 2. This will be 99. And this will be 1, 1, 2. So the next question is, what is 1, 2, 1? What's the character for 1, 2, 1? What's the character for 1, 2, 2? What's the character for 99? How does a computer see 1, 2, 1, and so on? This table will tell you what they are. If you check this table for, if you check for 1, 2, 1, so this 1, 2, 1, 1, 2, 1 is Y, small letter Y. Then 1, 2, 2 is Z, that's small letter Z. Then 99 is O, that's capital letter O. Then 99, let's check it out again. So sorry, 99 is C, not O, it's on the right, so it's C. Is C. And then the last one, which is 1, 1, 2, that's P. So it means instead of sending love, Bob is going to send, Alice is going to send Y, Z, C, P. So this is what will be transmitted to Bob. This is how computer encrypts information before sending. But the interesting thing is, if Bob should perform this exclusive OR operation, Bob will retrieve this LOVE. But before you can retrieve this LOVE, you must understand, you must know the key that was used. So what Bob will do then is, Bob will take this Y, convert it to number, which is in base 10, then transform it to the base 2, add this key, and that will lead to 1001100, and then that will lead to 76, that will lead to L. So what Bob will do is just to reverse this process. This Bob will just take the Y, convert it to 121, which is base 10, to base 2, add this key to it, and it will give this base 2, then eventually 76 and L. That is exactly how, this is exactly how Bluetooth technology works basically. It's been encrypted with a key, transmitted to the receiver. The receiver will use that key to reverse the process to get the original message. But the point here is, if you don't have this key, you can't decode the message. This key is the secret to unlocking and locking that message. So that's why whenever there's a transmission of data, only the receiver and the sender gets to know the key. If any person in the middle gets to get the key, the person will be able to get or interpret whatever information is being transmitted. So this is just to give you an idea of how number-based system is applied in real life. And I hope you enjoy this discussion.